So the HK form is f of x equals a times, it's read a times, the absolute value of x minus h. Can you guys see that in the HK form there's always a minus right there? Yes, it will always be a minus right there. And then plus h. The a, the h, and the k is what we will try to understand today. Now, because it's an absolute value, we also have a piecewise. In a little bit, we'll explain why a piecewise is also applicable for an absolute value function. Okay. So we have multiple explorations. We'll start with the first one. Exploration number 1. Graph the parent function, y equals absolute value of x. Do you guys have a straight edge ready to go? If you don't, can you go grab one? So we are going to complete this together because I don't think you've ever seen an absolute value function done. If you did, great, okay? And then we'll leave a few of it for you guys to do alone. So on this table, how many inputs are you given? 5. That means you are to look for how many outputs? Perfect. Find it, and then let me call on you to give me. So in your notes, find the 5 outputs. Dahlia, what are your 5 outputs, hon? Is it -1 and -2? It's 1 and 2 because absolute value of all numbers will always be what? Positive. All right, so class is 1 and 2. All right, plot it for me. At -2, you go up -2, -1, -1, 0, 0. 1 is 1 and 2 is 2. Raise your hand if you know what shape this makes. It's close. It's close to a parabola, but it's not a parabola. It's a V. Good job, whoever said V. Okay. It's totally a V, okay? That means you need a corner down here. It's a V. Okay, that's why you need a straight edge. Do not round out the bottom, because if you round out the bottom, it's a whole different curve altogether. So the bottom, this very, very bottom, anybody know what that would call? What would we call that bottom? There's a term for it. It's a vertex, and the vertex happens to be at or on the origin. Okay, so that's a vertex. And then we're going to figure out this table. This table will never go away for the remaining days in Algebra 2. Vertex. What is the point for the vertex? What's your h and k value? 0. Yes, 0, 0. Do we have an x-intercept? It's also at 0, 0. Okay. What's the domain? All real numbers. Will I also accept interval notation? Sure. You don't ever have to ask again. Either one, as long as it's right, I will take. Well, this one said increasing interval. Do we have an increasing interval? Increasing interval, by the way, do we always go to the right? Okay, so increasing interval, what do I mean by that? Or decreasing, because decreasing is on the right side. What does it mean by increasing interval? What's happening? Positive slope. Positive slope meaning is the y positive or the y negative? Or is it going up or down, I should say? Y is going up. So, always move to the right. Take your pencil, move to the right. Is there any time on this V-shaped absolute value curve that the y is going up? Where does it start? Starts at 0. Where does it end? Nowhere. Nowhere. So what do we call it? Infinity. It starts at 0 and it ends nowhere. It keeps on going. Rate of change. Rate of change is fancy for what? Slope. Do we have any? In this case, we actually have how many? 2. Okay, one's a positive 1 and one is a negative 1. Okay. Minimum value is what we use to call the lowest value. Do we have a value of y that's the lowest possible? Yeah, it's 0. So minimum is 0. Minimum is 0 at the location of x equals to 0. Normally, for an absolute value, this is also the vertex, okay, for the, if it opens up. To the right side of your table, axis of symmetry. Anybody know what that is, Paris? Yes, so the line, when you fold it, the left and right, or the top and bottom will be exactly the same. So this happened to be here. Okay, this is axis of symmetry. Anybody know what that line is called? Y-axis. Is it y or x? Does it intersect the x-axis or y-axis? It's crossing over the x. Okay, it's on the y-axis, but it's really technically crossing over the x-axis. X equals to 0. Right. Now it's looking for the y-intercept. Do we have any? Yeah, the y-intercept and the x-intercept for this particular parent function is exactly the same. What's the range? Starting at 0 and it goes all the way to where? Positive infinity. Do I include 0? Yes, so there's a bracket. Starting at 0 goes to infinity, or can I, you can write inequality symbol. Y is bigger than or equal to. Do we have a decreasing interval? That means if I keep going to the right, is there ever a location or that y is going down? No. Sorry, you have a question, Maggie?
Yeah, y for the domain, and it doesn't have like a bracket.
The domain? Because the domain is all real numbers. Is that what you mean?
Oh, okay.
Yeah, infinity, you can't have an inclusive on infinity because you don't know exactly what that is.
Okay.
So all infinity would never have a bracket, just a parentheses. Good question. Okay, decreasing. What does it start and what does it end? No. It starts nowhere. So actually, technically, doesn't it start over here on the left side of what? Of negatives, right? So that's infinity. So negative infinity. Where does it end? At 0. Because from 0, that's where it starts increasing. Right, boys? Right. Is it a 1-to-1, Nathaniel? No.
Should we consider these 2 different lines or one?
Oh, good question. Let me answer that. Hold on to that thought. 1-to-1, yes or no? No. Hold that thought. And then we'll answer that after we answer the maximum. Do we have a maximum?
Yeah.
Infinity?
Is infinity a number that we can use right now? No. If it's ever an infinity, we say none or not applicable. So I will say none, or you can write NA. Okay. Now, the question is, are these 2 different lines? Yes. That's why in the, this is, you don't have to know this piece, but it says, can you guys see this? It says piecewise. Technically, currently, this one said there's only one function. The function is y equals to absolute value of x. But if I were to use piecewise, would you agree I could write it like this? F of x, this is extension. How many pieces? 2. You're right. The first piece, this is just an extension. Would you agree? The first piece is x is less than 0, and the second is bigger than or equal to 0, or vice versa. You can switch those in, okay? Would you agree? The first piece, because x is less than, it has a negative slope right there. So that's really a -1 slope, and then it intersects at the y value of 1. I mean, I'm sorry, it's 0. So technically, I don't have to write 0. And then the second piece, it's a +1 slope, and also intersecting at the y-intercept at 0. So for piecewise, okay, we use piecewise sometimes to write absolute value function because they're just two lines. Good question. And again, this piecewise is just an extension, okay, just an extra credit. Yes?
For the increasing and decreasing, how come 0 is increasing?
Good question too. Actually, 0 is not inclusive in algebra. When you guys get to a higher math, some books will include it, but for our case, we won't include it. And here's the reason. At 0, technically, it's the beginning or end of the increase or decrease. Would you guys agree? Okay, so at 0 right here, would you agree that's the end of your decreasing interval or beginning of your increasing interval? So technically, how do we know which one it includes, which one it goes with? So some books will use a non-inclusive. So you can use non-inclusive and some books use inclusive. Either way, it's okay. So you can put a bracket there or you can just use a parentheses. Okay? All right. Any other questions on the parent function? Your first parent ever. Crazy. Now, the difference between all parent functions. Okay, so if you look back here, can you see that the parent functions, in this one, the parent function, it's pretty boring. Does it have an a value? Is there an a value? What's an a value here? It's just a 1, right? Pretty boring. Does it have an h value? Do we add anything inside? Do we subtract anything inside? No. Does it have a k value? No. So the parent function is usually the boring one. You guys are the fun ones. Okay? All right, next. 2. I would like you and your team to fill out the outputs. 5 inputs are given. You and your team fill out the outputs. Brandon, what are your 5 outputs, hon? Good. -2. Perfect. So graph it. -2, -2. -1, -1. What shape is this, Olivia? What shape should we have? What shape should we have? A V, good. An upside down V this time. Guys, can I make a U out of this? No, I will mark it incorrect to make sure we don't make a U, okay? Don't round about the bottom, or in this case, the top. Okay, I want in your team, I would like for you to compare this to the one above, the parent function, and make a list or write incomplete sentences of all the things you can see that's different or the same. Just compare them. How are they the same or how are they different?
Same vertex. Yes.
So Madeline, give me one comparison.
Like what's same? It's different because they're all negative.
What's negative?
The y values.
Do you guys agree with Madeline? All the y values are negative now? Totally. Y values are negative. This causes to open how? How does it open if all the y values are negative? Down, opens down, okay? So we'll just add that on with Madeline. Opens downward or down because I'm out of space. Now, what's another comparison that you saw? Santana? Oh yeah, same vertex. Any other comparison that you saw? What else? Is that it? Same inputs. Yep, we didn't change any of the x's. Anything else? Same input, but the outputs are opposite. Okay. How about the size? Is it any bigger or smaller besides opening down? Same size, right? So same size. Okay. So in general, make a statement. If the parent function is multiplied by a -1, The only difference is the outputs and the opening of it, right? It opens down. So formally, when it opens downward, we call it reflect. Reflect. Some of you call it flip. Reflect or flip over which axis? The x-axis, over the x-axis. And let me tell you a secret. This is true for all functions. So later when we study crazy functions, this will never change. So if you take the parent and you multiply by -1, the transformation is just simply reflected over the x-axis. Okay. Right, next, 3. Do the outputs. You got 5 inputs, do the 5 outputs, and then make a list of comparison. What do you see? Remember, we are always going to compare it to the parent. Okay? We are the product of the parent. So once you have the 5 outputs for exploration 3, I would like for you to graph it out. Chizuki, what are your 5 outputs, hon?
4, 2, 0, 2, 4.
Thank you. 4, 2, 0. Sophia N, what shape should we have? A V, good. Because guys, I really don't want you guys to draw a U, and because that's a whole different function altogether. Okay, go ahead and compare that to the parent. In your team, compare it, and then I'll just call on one of the teams to give me different comparison. Mariana, what's one comparison that you came up with for to the parent? Same vertex still, excellent. I like it. Okay, and what's another comparison? Han, what's your comparison to the parent if you have one? Ooh, I like it. What do you say, thinner? Skinnier and taller. Ooh, yeah, skinnier. I'll fight skinnier because that's your word. Skinnier and taller. Okay. Wow, perfect. What is your one, Maggie? What's your one comparison if that's not already here? Perfect. Same. All inputs are exactly the same as the parents. What's your, Autumn's not here. What's your, Christian, what's your one comparison if you have it? Slope. Different from the parents. How different? What are you saying? Oh, so like twice as much? Okay. Different slopes. Okay. Twice as much. Anything else, Elena, that you can come up with that's not already here?
Goes in the same direction, like they're both upwards.
Okay. Opens up. Okay. So it looks like the difference is it's skinnier and taller. Would you guys agree? The vertex is still the same. It still opens up. So the difference, the only now difference is skinnier, aka taller, That means the y value, because the question said the slopes are different, the y values are twice as much. Why is it skinnier? Yeah, Brendan?
Because like the output is like higher.
Yeah, you're multiplying the y by how much? 2. The y value got twice as much. So that's why it's skinnier. Would you agree, since the inputs are exactly the same? So this is what we're trying to understand. Since the y values are changing because we multiply by 2, y value goes up and down. Would that be a true statement? Is that vertical or horizontal? It's a vertical. And because question said, oh, y value got twice as much, is that a stretch or a compression? It's a stretch. So guess what? Make a general statement. If the parent function is multiplied by a number that's positive, that's bigger than 1, then the parent function is a vertical. Okay, so we call it a vertical stretch. Okay, and we use this fancy word called factor over a. What's the a value in our example? I.e., in this example, a was what? 2. So on an assignment, when I ask state the transformation, we would state vertical stretch factor of 2. Okay? Can a change anywhere from 1.5, 1.1 all the way to a million? Yeah, as long as positive and as long as it's bigger than a. Then it's always going to be a stretch vertically because we're multiplying the y by a bigger number. Okay. All right, try 4, exploration 4. Exploration 5 will be your last one. Once you're done graphing it out, I would like for you to fill in some comparisons there. Okay, 5 outputs are, let's see. Ben, can you give me 5 outputs, hon?
1/2, 1/4, 0, 1/2, oh, 1/4, and then 1/2.
1/4 first and 1/2?
Yeah, 1/4, then 1/2.
Thank you. Perfect. All right. Ooh, the y value is super tiny. So -2, go to positive half. -1, it's a quarter. Then 0. Do you guys agree with Ben's 5 outputs? Yeah. So make sure we have those. What shape is this? A very, very wide V. You are right. Okay, it's always a V, class, if it's an absolute value function. What if I make a U? Not okay. Okay? Not okay, okay. Okay, go ahead and you and your team compare. What's the difference? How is this different from the parents? Hi, Emily. Can you give me one of your comparisons?
It's a lot wider.
A lot wider. You are correct. Good observation. Okay, wider. Slater, give me one of your observations. Same vertex. You are correct. Same vertex. Excellent. Diego, give me one of your observations that's not already here. Compress. Ooh, I like the fancy word. Okay. Alyssa, give me one of the comparisons that's not already up. Inputs are smaller. Is she correct? Inputs, are they smaller? Inputs, are they the same? Okay. Same inputs, but different. Same inputs. And you said smaller outputs, right, Lisa? Okay, smaller outputs. Very good. How much smaller, Lisa? Do you guys know how much smaller? A fraction? What fraction? A fourth of its original size. Would you guys agree? If it used to be a 1 on the output, it is now a fourth because it's a fourth smaller. Okay. Anything else that you would like for me to add that's not already up? So, why is the graph so much wider when the inputs are exactly the same? What happens? The outputs got what? Smaller. And then some people use some fancy word, compress. Okay? What happens when you take, let's just say me, same person, same parent, and you squish me this way? Right? I'm going to read it fatter this way. Would you guys agree? So all the fat goes out the sideways. Okay? So, when you take a function and you squish it, what direction is this? Up and down. And in math, what do we call it when it's up and down? Vertical. You're right. So here we go. So if you multiply your parent by a value that is positive and that is in between 0 and 1, okay, that means you're going to have a function. The parent function is now going to be called vertically what? Compressed, okay, by a factor over a. In our example, in this example, a was what? A fourth. Okay. All right, last one of today, and we'll call it an egg roll after this. This one has lots of inputs. Oh my. Huh? Okay, so I'm gonna call on you guys. Give me the 5. Oh, not 5 actually. How many inputs did I give you this time? Let's go. Output. Once you guys have the output, graph it out. Are you done with your 500? Are you sure that's it? Compare with your friend. So basically all you're doing is so that's why these are positive. Yeah, the only way it's going to be negative is that X is on the outside. Miss Sophia H., can you give me all of those outputs? 4, 3, 0, 1, 0. Shh. Erase? What? You said, I'm sorry, okay. Erase? 4, 3, okay, 4, 3, what else? Sophia? 2, what else? 1, what else? 0, what else? 1, 2, 3, 4. Class, Do you subtract the 2 first, then take the absolute value? Yes. You got to do the inner first, okay? All right, let's plot. -2, go up at 4. -1, go up to 3. 0 at 2. 1 is 1. Oh my. What shape do we still have? V, absolute value. As you can see, it doesn't matter what I do to the parent, it's always going to be a V. Okay. You guys change slightly from your parents, but generally we still look the same, right? Okay. Oops, I shouldn't have. Ooh. Okay. So let's compare this to the parent. Okay, Naomi, give me one of your comparisons.
It's a different axis of symmetry.
Good. I love it. Shh. Different axis of symmetry. I like it. Different AOS. Someone else raise your hand and give me another comparison.
Different vertex.
Yes. Different vertex. Okay. Alyssa, give me one comparison. What else?
Different inputs and outputs.
Different inputs. Shh. A lot more. Okay. So looks like different inputs / outputs. Would you guys agree that inside we have done what? What did we do on the inside of the absolute value symbol? We took away 2. When we took away 2, what happened to the parent? Where did it go? Did it stay the same? Did the vertex stay the same? No. Where is the vertex now? At 2, 0. So, where did it move? Up, down, left, or right? To the right. Whoa. When you took away 2, it moved to the right how much? 2. Moved right 2 units. So, now let's remind ourselves. There's an H value, right? What's your H value in this question? H is +2 or -2? Let's remember, our equation was A times an absolute value of X minus H. Hold on, would you agree that it's always a minus inside? Shh.
Yes.
So if always a minus inside, that means this H is a +2. If H is a +2, you move what? Move right. Move right H units. Okay? Move right H units, whatever H is. All right, guys. Hasta mañana.